Hello, students. I'm Coach Jackson. I'm going to go through you with another example of solving systems, 3x3 systems by substitution. Miss Gable has already went through several examples. I'm going to show you one more example of one that works. All right. So first of all, this is a 3x3 system because it has three equations: 1, 2, 3, which I have labeled 1, 2, and 3, and three variables: 1, 2, 3 variables: x, y, and z. So that's what makes it a system, a 3x3 systems of equations. We're trying to find a solution to a system of equations. If you remember correctly with Miss Gable, the solution is going to be where it makes all three of these equations true. X is going to make it true, y, whatever value you get for that, and z is going to make these values over here for all three systems. If you were graphing it, they all will intersect at some certain point. All right, so let's go get through this solving by substitution. So the first step you have to do is pick a variable to solve for in one of the equations. Pick an equation and variable. I am going to choose equation 1, and I'm going to choose x. Why am I choosing x? Because x is almost by itself already. So I'm going to write this equation down below this line so I can know where I'm starting. And I'm going to isolate the x, solve for x in this equation. So to solve for x in this equation, I need to subtract 2y and add z to the other side, do the opposite operations. So let's do that. Subtract 2y, add z. I put a line through my z so you can tell the difference. My handwriting is not the best, so I want you to be able to see the difference between a z and a 2. So when I did this, I'm going to write this in blue just so I can see it. My first equation is x equals 9. Because these are not like terms, you can't combine them. So I end up with 9 minus 2y plus z. One thing I want to point out, what I'm really trying to do, because I have three equations and three unknowns, I need to narrow this stuff down. I need to get it down to two equations and two things I don't know. And then I'm going to take those two equations and get those down to one equation and one thing I don't know. I started off with three equations and three things. I'm going to narrow it down to two. Then I'm going to narrow it down to one. And then with that one equation, I can solve it. So the way I'm going to do this is by substitution. So I isolated the x to get it by itself. Now here comes the substitution part. I am going to substitute into the other two equations, equations 2 and equations 3, what I got for x. I got x is equal to 9 minus 2y plus z. So in place of x here and here, I'm going to put 9 minus 2y plus z and then write the rest of the equation. If I'm talking kind of fast, just kind of replay this and watch it again. So in place of x in the second equation, I'm working with the second equation to get a new second equation. This will be my new first equation. I'm about to get a new second equation. So in place of that x, let's put 9 minus 2y plus z in place of x, and then I write the rest of the equation down exactly like it is. So I have minus y plus 3z equals negative 10. And then I start to solve. So since this is already, there's nothing in front of it for me to distribute, I really don't need these parentheses. I put it there to let you know that this is really x. So this is really x right here. That's why I put that there. Now, but let's go ahead and start combining like terms. Since there's nothing there, I can drop the parentheses off. So I got a negative 2y and a negative 1y. That leaves me with negative 3y. Z's, I have z and 3z. So that gives me 4z. I didn't do anything with the 9 yet, so I'm going to write the 9 down, equals negative 10. So to make this look clean, I'm going to subtract the 9 to the other side and end up with negative 3y plus 4z equals negative 19. This will be my new equation 2. Okay? Over here next to this, I'm going to do the exact same thing, except I'm going to plug this that I have for x, my new equation 1, I'm going to plug that into equation 3 to get a new equation 3. All right, so let's do that. In place of x, I'm going to put 9 minus 2y plus z. In place of x, I'm going to put 9 minus 2y plus z. And then I finish writing the equation. So plus 6y minus z equals 27. Okay? And then I have to, in this case, since there's an operation in front of, there's a number, 2. 2 has got to be multiplied to everything. So then I end up with 18 minus 4y plus 2z. And I'm writing the rest of it down before I combine my like terms. You're doing the same steps over and over, ladies and gentlemen. You're just going to do the substitution into the part. So now I combine steps just like I did over here. Combine like terms. I have a negative 4y and a 6y. That combines to 2y. I have a positive 2z and a negative 1z. That combines to just 1z. I'm just going to write z. I still have this 18 equal to 27. So to clean it up, to make it look like this, when I subtract the 18, and I end up with 2y plus z equals 27 minus 18 is 9. So that would be my new equation 3. All right. So now I'm going to combine. So I told you at first we're trying to get down. We started off with 3 things we don't know. Now 3 equations and 3 things we don't know. We're now down to 2 equations and 2 things we don't know. So we're going to take these 2 equations and guess what? We're going to start all over again. Oh, yeah, I know. So I end up writing these 2 equations, and now I'm down to 2 equations and 2 things I don't know. So I'm going to take these 2 new equations, and I put them together, and I got to figure out which variable do I want to solve for in which equation. I'm going to use my new 3 equation. I'm going to solve for z because z is almost by itself. So when I solve for z, I'm going to write that right here. In order to solve for z, you have to subtract you subtract 2y on both sides. Since these are not like terms, you end up, and I'm going to write this in, let's say, let's keep it in black. Z equals 9 minus 2y. So there's something I have for z. So, like we did up here, we plugged it into the other 2 equations. We're going to plug this into the second equation. So in place of the second equation, in place of z in the second equation, I'm going to put 9 minus 2y. So let's do that. Negative 3y plus 4 times 9 minus 2y. I substituted in equals negative 19. All right. So I solve this. Distribute. And I end up with negative 3y plus 36 minus 8y equals negative 19. Same steps. After you distribute, you combine like terms. In this case, we only have y's to combine. So I end up with a negative 11y plus 36 equals negative 19. Okay? Now, subtract the 36 on both sides to try to isolate the y. We're starting to get somewhere, y'all, believe it or not. That gives you negative 55. And then your last step for this part is to divide by negative 11. And I end up with y equal to 5. Woohoo! Finally getting somewhere. So once you find y, you're going to go all the way back up to, we found y. You see right here where we already solved for z and it has y here? We're going to substitute in place of y what y is. I'm going to substitute in right next to it so I can get z right quick. So I end up with, do this in a different color. I'm going to do this all in blue. So z is equal to 9 minus 2 times y. Y is 5, so I'm going to put a 5 right there in place of it. Okay? And so now I end up with z equal to 9 minus 10, and then z will be equal to -1. So I found z and I found y. I have one more variable to find. I have to find x. You see right here where I have that one underlined, a new equation 1? Well, I have a y and a z. X is equal to 9 minus 2y plus z. So over here in this little blank space right here, I'm going to work that one out. So I end up with x is equal to 9 minus 2 times y is 5 plus z is -1. And I'll work this out. So I end up with x equal to 9 minus 10 minus 1, which tells me that x is equal to -2. So I have to write this as an ordered triplet. We're done. I have to write this as an ordered triplet. My ordered triplet is always in the order x, y, z. So in this case, my ordered triplet would be -2, 5, -1. And that would be your solution. You can always check your solution by plugging it back into the original problems. So if I plug those three solutions back into x, y, and z in the first equation, x, y, and z in the second, x, y, z in third, and see if they give me the numbers on the right. And in this case, they do. I'm telling you they do. So the solution is -2, 5, -1. All right. I know that's long. I know there's a lot of steps, but realize that you're doing the same steps over and over. So you got to get down from starting off, 3 equations, 3 things I don't know. I chose a variable to solve for, x. I narrowed it down to solve for x. Now I plug that in, substitute it into the other 2 equations. That's what I did here and here. And then when I did that, I narrowed it down to just 2 equations. New 2, new 3. All right. So then I got it down to 2 equations. Now I got to get those 2 equations down to 1 equation. I did that all the way here. And then once I get it down to 1 equation, I can solve. And find y, I found z, and I found x. X, y, z. All right. I hope that helps.